number 3. So this is the number 3 from the yellow tension sheet. Let's do it. First of all, there's no friction, right? We have a hanging mass of 19, and you have an 11 and 5 block on the table. So it's a little different because now there's 2 different ropes, right? So we have a tension force here, and I'm going to call this FT2. And this one should be the same, but it's FT1. Oh, sorry.
No, that's going to be FT2 as well.
Thank you, you're right. Yeah, same string, cross on it. And then this one is going to be FT1. And this is also FT1. So these 2 are the same, those 2 are the same, but those 2 are different. So the tension in each rope is different. Okay. If there's no friction, what's the gravity force here? This is going to be 190 newtons for making 9.810. And if there's no friction, we can negate the tensions, and we can negate these gravities and normals. Do you agree? So what's the net force on the whole system?
109.
Good. It's the only one left, right? Oh, let's make sure this is positive and this is negative. Okay, so everything this way is positive, everything that way is negative. If we want to find our acceleration, we can divide this by the total mass, which is going to be 35, it looks like. If you add those all up, I think you get 35. And that's going to be, what is it, Grosh? Okay, let's try. Well, 35 is 70. Oh, you ruined it for me. Oh, dear. Before would be, 140 would be 4, and then another one would be 175, so yeah, 5.4 or something like that?
You're just too much.
5.43. That's our acceleration. So what's the acceleration of this block?
5.43.
5.43. What's the acceleration of this block?
5.43.
5.43. What's the acceleration of that block? 5.43. They're all the same, right? Okay, so do you want to do all the blocks or just one?
All the block.
Okay. So this is how I would do this. There's kind of a strategy to this one, which ones you do. If you try to do this one first, it won't work. Because you have 2 different tension forces and we don't know either one. So you can't do that one to begin with. You have to either do the hanging one or the end one. I like doing the end one because it only has one force, really. It has gravity normal, but they cancel, so really the tension force is the only one. So let's do the net force on this 5 kilo block. That's going to be 5 times our 5.43. And our net force will be
27.
good, 27.1, let's say. And because there's no other force really here, the net force is equal to FT1. So now we know FT1. Don't have to do the subtracting because there's only one force on the block, right? Now you know this force, so you can look at this 11 now because you know this one is going to be negative 27, right? So if this is 27.1, this one is negative 27.1. You get that? We just know that's true. If we are right, both tensions are equal and opposite. So let's try to do it with that one. Or do you want to do this one first? You want to do this one? The hanging? Okay, let's do the hanging one. We'll check it with the middle block. Let's do the F net of the 19. So that's 19 times our acceleration of 5.34 or 5.43, sorry. 103.2 or so. And that's the net force here. And that's equal to gravity and FT2. And we want to find the FT2, so we're going to subtract our FG, and that should tell us our FT2. So this F net we said was 103.2, we found it here. And it's minus this 190. And that's going to be negative 86.8 or so, Karosh says, and he's right. This is FT2, so that's the tension force in the second rope. Okay, so we have a tension in rope 1, and we have a tension in rope 2. If we're right, we should be able to add those two together, and it should give us the proper acceleration for this. Except that, so this one is negative 86.8, but this one will be positive 86.8. Does that make sense? Okay. So if I draw that 11 block right here, I'm going to have pushing forward 86.8 and backward is going to be 27.1, right? Negative. If I add those together and I get the net force on this, 86.8 minus 27.1, 59.7. If you take that and divide it by 11, what do you get? You get 5.43, and then we know we're correct. So we did this one and we did that one to find our tensions, and if this works, this is like a check. And we checked that and it gave us the correct acceleration, so that's how we know we're right. You don't have to do this part. It's just to see if you were correct or not. Okay, do you want to do the friction part? No.
Sorry, Mr. Swinton.
Yeah.
It asks, as part of the question, that what's the tension in the string of point A and point B? Would you just write the same thing, because the tension supports the tension?
Yeah, so is this A?
The next one over is A,
This is
and
A?
the other one is B.
Okay, so this one would be our FT2,
Yeah.
the 86.8, and this one would be the 27.1.
Okay.
The tension is the same all the way along the rope.
So it
Oh,
doesn't matter.
then why would the other one, would the other one, would the second one also be, not also be 86.8? Or
This is 86.8, like all the way along this rope is 86.8.
Oh, okay.
And all the way along that rope is 27.1.
Oh, okay, so they're different. Okay.
Yeah. Charlie. Yeah. Should I stop this or do you want to do the friction too? It's the same thing we did with the other one.
But like,
Okay, I'm gonna stop this one.
say like the tension is in A, can it